So this slide shows you the TIMBUS approach. We have a three-step approach. We plan what aspects of a business process need to be preserved. Then we preserve it, and then we redeploy it. And this is drawn as an iterative circle because you're not going to get it right the first time, and you need to test and you need to validate that what you thought you should preserve will actually enable you to reconstruct the functionality that you had in mind. So I will walk you through each of these steps, and then I will give you an example that we've worked through in the last year. So in the planning step, we need to capture all the components of the business context, similar to what I've shown you on the big key diagram. And we need to capture the dependencies between the context component and the process itself. When we've done that, we need to study legalities. We need to see other licenses, laws, regulations, statutory regulations that force us to do things differently with preserving it now, or that might keep us from redeploying things in the future. And we need to look at the risks that exist to the business process. So which parts of the business process are at greatest risk? Which ones have the biggest impact on our organization if they fail? We have a chicken and egg problem here. If I describe the organization completely and I gather all the context components, I'm really going overboard. I wouldn't want to do that. I just need to identify the relevant things. So I really need to have it risk-driven. I need to understand what the risks to my process are, to identify which the relevant components are, but I can't understand what the risks are unless I have understood at least partially what the context is. So again, we've made that an iterative process because you need to basically go through this, feed the legal problems into the risk aspects, make the risk fuel which context components you choose and preserve until you reach a stable state where you feel like all the significant requirements that you have can be satisfied with the context description that you've created. In the preservation step, again, we have an iterative cycle where we end up virtualizing the business process that we've planned here, we store it and we validate it. And in the redeployment, we reactivate the business process. Now we are in a new environment where somewhere in the future and the platform looks different from what it used to look. So it means we have to support the integration of the functionality that we have documented in the new environments to get the business process started in the new environment. And we need to validate what we've done here. With this approach that I've just illustrated, we also have developed an architecture, and I will not talk you through every detail of the architecture. I just wanted to give you a flavor for it. So Wasif's team has put together an architectural descriptions of all the modules that need to be implemented, the GUIs, the storage components, and so on. And you can get that document from us. It'll go up on the web very soon. So it mirrors the approach. There's an acquisition module that gets all the information from distributed digital preservation agents that give you information about what software is, what dependencies are there, what static and dynamic dependencies are, what is the business process actually and its functionality. There's a risk management module and a legalities module, and then the DP engine will do the preservation and the redeployment. So I've given you a course idea now what we want to do, and we have developed a very small use case to illustrate the whole process, and I'll walk you through that now. We had 3 driving big use cases, but they're too big to show in a training event. So we'll just do this music use case. It's an actual use case that we're using. We have a PhD student from the University of Vienna, the Technical University of Vienna, and what his research is about is he learns rules for classifying music. So the way this works is, at the bottom it says get ground truth. Basically what you have MP3 files or other music files, and a human has already classified that, said this is classical, this is salsa, this is blues, and so on. And then he takes learning samples. He takes MP3 files, which he gets from the cloud, and he does a feature extraction on it. And he, based on the ground truth, he has learned rules that say if we have this speed or rhythm or these chords in it, then this seems to be classical. If it has other features, then it seems to be blues. And so he goes ahead and does learning samples and tries to predict what the category is. And so he wants to document how he has implemented his algorithm so that other researchers can redeploy it, they can test that what he did made sense, was best practice, and they can build on it. And so he has taken the TIMBUS approach and implemented it. And I will now take this to walk you through our approach and show each bubble in this example. So he started by trying to capture the business process, and there are lots of different possibilities. So what you see on the top here is a BPMN diagram, and BPMN basically lets you represent the steps and the connections and the forks and branches through an XML schema, for example. You could use Petri nets. They've tried Petri nets. Wasif will talk about a business continuity management system later today, where they already have a database model inside, I suppose, which captures the business processes. So there are lots of different implementations that you could have to capture the business process. One interesting thing they have done at the University of Vienna is figuring out if you have purely digital workflows, can you use workflow engines in order to capture the business processes? So they have taken 3 workflow engines, Taverna, Kepler, and Activity, and compared them how easy it is to capture a business process description using this. So this is an example with Taverna. Taverna is basically a programming workflow engine that is graphically assisted. You can plug in services or software. You can connect it. You define the input. So here go the learning samples in MP3 URLs. Here go the ground truth URLs, then you fetch the HTML documents, you get the MP3 file name. So every piece of software or service that is called is listed here in a little box, and they're connected, and the output from one feeds as an input into another. So this is a way of both implementing the algorithm so you can run it and documenting it at the same time. And if you do that, you capture a lot of information already. So you capture the process specification, inputs and outputs, all the URLs, the data, the documents. You capture the internal and external services that are used, the information about the software version, runtime environment, libraries and DLL scripts, and additional specifications. So there's a lot of information, but all that is only software-related information. But that's a good start. Yeah?
What did you say this was, what was the workflow engine you used?
It's called Taverna, and it's being developed at the University of Manchester. They're also using it in other EU projects. Scape is using it, for example. It's pretty popular at the moment. So as you're getting an idea of how complex this is. So we've only captured the business process and some software specifications. Of course, if I want to preserve this music process, for example, so I can diagnose it later, I might have different risks in mind. So one risk might be, well, were the training sets poorly chosen? Were they, for example, only choosing training sets from one category, so we can't really properly learn about other categories? So if you want to answer that question, you need to ask yourself, what other information do I need? So I might want to know things about what sampling methods did they use, what were the actual test sets that they used, what were the test methods, how did they react if there were exceptions. We might consider storing process logs the quality criteria, requirements, policy, and so on. So it's basically, here you already see how we interact with risks and context choice, because obviously we only choose the relevant aspects to the risks that we want to address.